Hello, welcome to the part 2 of page replacement strategies. We'll be discussing LRU and optimal in this strategy. So for that, what I'll do is I'll copy my fifo function and I'll make certain changes to get my LRU thing. So yeah, LRU. And yeah, after doing all of this, we can also print our miss and hits. So hits is equal to comma hits and miss is equal to miss. So we can compare all of these three strategies. So we'll do that. We'll print it out. Yeah. Now our replacement strategy was present in this section. Okay. Page replacement strategy. So what I'll do, I'll just cut it out, and here we have to implement our LRU strategy now. Comments in Python are different. This is the LRU thing, and what we'll do in LRU, for any page, what we have to do, we have to scan the string on the left, and we'll find out the page which is currently present in the memory and has the maximum distance in terms of the position in the string. So let's do it. Over here, when I get a miss, what I'll do is I will see, initially what we'll do is we'll keep doing this, and when our memory is full, okay, when it is full, then what we'll do, we'll assign when our memory is full, then we'll see our replacement thing. Or maybe we could do it is greater than or equal to msize, then it will work. And here we'll scan the string on the left first. So let's slice the string. So page string we have to slice it on the left, and for that we cannot just loop it like this. We need to have a range for that. So for I in, I'll say range of page string ka length, and wherever there was I mentioned, I'll replace it by page string of I now, because I have made some changes in my loop. Page string of I. Let's see, wherever there is I. Okay, there's one over here. Yes, so these are the changes we require to make, and we will have the left string slicing. What we'll do, till ith position, and we've sliced the string, we've gotten this string, suppose for example, and we will find out whether in this string we'll have to keep a track of distances first. So let's see. We'll implement a dictionary for this, okay, or maybe we could just have an array, and yeah, we'll have an array for page number 1, page number 2, page number 3, likewise it will keep a track, and our page numbers are ranging from just 0 to 9, so we'll have an array in this case, or we can also use a dictionary. It's up to your preference. So let's give an array for storing distances. Distances is equal to initialize all distances to -1. For range 10, 0 to 9 will just be 10. Then we'll also have another array, a present array list, which again will be initializing it to -1. then for j in range 0 till 9, that is, this is not counted in range, so 0 to 9, we'll see whether it is present in our left. Okay, it is present in our left. If or instead of that, we can just loop in our left for j in left. We'll have a integer of j. Okay, and what we'll do is distance of k minus 1 equal to, oh yes, we'll need a range in this as well, because for see, for each and every item we need its location also, so we need a different kind of a for loop. So yes, so for j in the range length of left, k is equal to integer of left of j, and distance of k minus 1 is equal to, now on left j will go from 0 to 5 in this case, and on 6th position is 4, so obviously the distance will be I minus j in this case for our distance to be positive. So I minus j, yes, that will be our distances, so distances will be initialized. Then again we'll scan our left string. Do we need to do that again? We can do that in the same loop as well. We'll check whether it is present in the memory, so we'll run a loop in our memory for anything, let's say L in memory. If L equal to left of j, if that's the case, meaning it is present in the memory, what we'll do, present of j, present of k plus 1. One minute. This gets us the integer, yeah, minus 1, correct. If it is present in the memory, then we'll just initialize it to 1. Or we should initialize it to its location. Yeah, we'll initialize it to its location, and then we could just break. Once it is encountered, then we need not loop through entire stuff. So after this, we'll have an array of distances and present things, and then what we'll do is let's print it out first, then we can clear up stuff. Present let's give the same page string 4. We've not called it, Let's call our LRU function. Let's do the same thing again. There's an issue. List index out of range. Time 34. You see, if it is going out of range, we'll keep this condition in the else part, so it won't go out of range in any way. Oh. I'll just copy my string from here. Yes, now it is not going out of range. And yeah, let's try printing our memory. Now we'll see the output. Initially it is assigning memory, that is correct, and RR distance is correct, that we have to check. So for 0, the distance between 0 and 4 is 3. Okay, distance between 1, let's see the final distances. We are looping through the left string, and in the left string we take out the pages in k variable, and we initialize the distance of k minus 1 as I minus j. Yes, the distance seems correct. For preventing confusion, we'll assign it to its location only. The number we encounter, we'll assign it over there only. Now let's see. We have to see whether our distance array is working correctly or not. So I'll just print it only once. Now let's see. So distance between distance between 1 and 4 should be 3. Is it so? It was 3, but after that it has incremented it. So maybe it oh yes, our distances are correctly working. It's just that we haven't swapped it. Okay, we haven't replaced any pages, so it was showing the next distances. So for the first one, the distance is correct. One has a distance of like 3 from 4, 0 has a distance of 2 from 4. So likewise everything is correct. So after all of this, we'll check. Okay, in the same loop we are going to do it. in the left string. No need, we've scanned the left string. After that, what we'll do, we'll check which one has the maximum distance. So for that we require a maximum variable. Let's initialize it to 0. Then we'll scan our distances for j in distances. If if max is less than distance and present for max is j, or else we'll keep a range again. No need of that kind of loops. If max is less than, or let's say our distance of j is greater than max and present of j is equal to 1. Was our present array working? For that, no, our present array is not working. We'll have to debug this. Yes, now our present array is working. What I did was I missed converting it to integer. So it is working. So now, if the distance is max and present is not -1, if it is not -1, then what we'll do, we'll store distance of j in max, and we'll store, let's have another variable, let's name it num. We'll store present of j, and then after the entire process is done, we found out the maximum distance one page, we'll assign memory of num, that is present of j, is equal to the current page. Now the current page is stored in page string of I, so it will be page string of I. Let's try. Our previous string we'll take, and 4. Okay. 1 2 3 0, then 4 replaces 3, yes, 5 replaces 1, 5 should have replaced 1. There's some minor error in our code, and yeah, we have to convert it into integer. That's why it was showing us quotes. 4 replaces 3, that is correct, and 5 should have replaced 1, but it is replacing 0 for some reason. We'll debug that again. So for that, let's run our loop. After our loop, let's print the present locations, so we'll get an idea of what's exactly happening. So yeah, after this, these are the distances for 4, then 4 is placed. Then for 5, these are the distances, 5 and 4, the distance is, yeah, it should have been 1. the distance between 5 and 0 is 3, but it is showing 4. I'll try to correct it out. Okay, I found out the error. Over here we have to make it as its position in the memory, and at that position we are going to replace it. So we'll just test this out. One more thing, its position in the memory, we again need a range loop over here. We cannot make it as the item in the memory, okay? So that will be it. Memory of L over here. Yes, 5 replaces 1, 6 replaces 0, and hit and miss. Yes, it is correct. So making this video a little bit more long, we'll implement our optimal in this video itself. So in LRU what we did is we scanned the string on the left. Now in optimal we'll scan the string on the right of any of the current page. So for that, where was my loop running? My loop was running over here. In left string was this one. What I'll do is I'll go from I plus 1, and yeah, I'll start my journey from there. So it will be my right string. And wherever, okay, we'll keep it left for convenience because we'll have to replace below. And in our string, we will run the loop from, okay, this was 0 to left, right? We will run the loop from I plus 1 till length of page string. We'll run the loop, and the remaining things should be same, just that here our j will be greater than I, so we'll have to make the changes accordingly. So let's copy this. Let's predict the output beforehand so we'll know. So 1, 2, 3, 0. Then 2 is a page hit. 4 shall replace 2 in this case. Then 5 shall replace 1, and 6 will be a permanent miss. Let's see. 4 replaces, what has 4 replaced? It should have replaced 2. Again an error. Let's debug this. Oh sorry, there's no error. I have not called the function as of now, so let's call it. Out of range. Let's see on which line it was showing. So 76. See, this is what is causing the issue, right? So I'll just make it as page string of j. We don't require the left string in this case. We can just loop through our right string. We don't even need to store it in somewhere. So that will be it, I guess. Let's see. It it is working correctly, but the permanent misses which I had shown you, 6 will be a permanent miss. That is not happening. It is replacing some other page. So what I'll do is I'll keep a track whether it is present or not. Where am I replacing? Oh, I'm replacing over here, right? So if my num is not equal to -1, then I am going to swap. Still it's not a permanent miss. Try printing num values. Okay, num is initialized to 0, so it is replacing that. So let's make it as -1 because initially our distances and stuff are -1. So yeah, it is a permanent miss for 6. So that's what we wanted to show. Yes, so it is working correctly. So all 3 strategies have been implemented. So thank you so much for watching this video.